Hey guys, in this video we are going to be talking about another property, but this time it's only one instead of 17 bazillion. If you haven't checked out the last video, you can click the link in the iCard to get to the previous video about all of the properties, all the commutative, associative, all of those other things. It's right there. If you're in my course, you should have been watching them in order and all of that, but if you stumbled on here through YouTube, then you can get back to it using that. So let's dive in and let us talk about the distributive property. I forgot to slip my glove on here so I don't get stuff all over my screen. There we go. We should be good to go. All right. So the distributive property. If you had a really solid pre-algebra course, then like a lot of the other things in that we've seen so far, this is going to be a review just like everything else. So what does the distributive property say? Distributive property. I'm just going to put prop because probably if you've been following along and using the title card the way I intend it, you probably already copied down the title. So distributive prop. So what the distributive property says is that if we have A times B plus C, and actually this goes out to plus D plus E plus whatever, you could have a distributive property that kind of strings on forever, but we're going to write the example and the definition simply like this. That equals A times B plus A times C. Now, really often whenever we are actually doing this with numbers, and we're going to see an example like pretty much right now-ish, but we usually like to draw kind of like arrows going, so A times B and A times C, so that we can remember what we're doing. So we remember to distribute times everything, especially if those distributive properties get large. So let's jump in and take a look at an example. How do y'all feel about this new color, this little bit lighter gray color? I wanted something where I could use black and white in there as well and maybe show up some of the other colors. If stuff gets a little bit too funky, let me know in the comments or in class. So let's do an example. Here we go. So if we have 3 times 2 plus 5, all right, what we're going to do first is we're going to do this two different ways, right? We're going to do this kind of the just regular order of operations way, and then we're also going to do it the distributive property way. Now, you may be thinking, well, one way, the order of operations way just makes a ton more sense. Why don't I just do it that way? Well, the reason you need to learn it the distributive property way is because, and we'll see examples of this very soon, inside this parentheses isn't always just numbers. Sometimes we throw variables in there. So we're going to do this one the order of operations way, just good old-fashioned order of operations. This one we're going to distribute that 3. So we're going to do 3 times 2 plus 3 plus 5. So we've got 3. I'm going to write it all out, all the steps, okay? 3 times 2 plus 3 times 5 over here. And then over here, we're going to do the inside first, inside the parentheses. All right, so 2 plus 5 is 7. We're going to bring down that 3, right? Now, you're going to see that in this particular example, doing it just with order operations would be the easier, faster way. But again, this is kind of to prove the point that it does work, right? And it's not always numbers, right? Sometimes we got letters. 3 times 2 is 6. And 3 times 5 is 15, so 6 plus 15. And then jumping back over here, 3 times 7 is 21. And surprise, surprise, lo and behold, 6 plus 15 is also 21. So this example here is kind of, again, proving that it does work, right? So you can distribute it and do it that way, or you can do order of operations and you get the same answer, excuse me, either way. All right, so let's do let's do another example. Let me clear off what I've got here. Let's do another example. I'm going to kind of shift around on my colors. That way, if there's some color in here that's just not working real well on this new level of gray, y'all can let me know. All right. So let's do this example. And what we're going to do is the instructions are going to be distribute and simplify. Distribute and simplify. Okay, so this is going to be example number 2. And it's going to be 7 times 2y minus 3. Okay, so what we're going to do is we're going to distribute, right? We're going to distribute that 7 on both things, right? 7 times 2y. Now, what do we do with the numbers and what do we do with the letters? Well, what we do is really, really simple. We multiply the coefficients. Remember, the coefficients are the numbers in front. So we're going to do 7 times 2. And the y is just going to come down and hang out. This is not 2y. It is 2y, but doesn't become y squared or something because we're not doing y times y. It's just 2 times y times 7, right? And that's important that we keep that separate. Later, we're going to learn about exponents. And if you don't get this drilled in really well, then it's easy to accidentally do different things. So for distributive property, we just multiply the numbers and bring down the letters. Simple as that. So then we're going to do minus, and then 7 times 3. Easy peasy, right? No big deal. 7 times 2 is 14. Got to bring down the y. Negative 7 times 3 is negative 21. 14y minus 21. Now you notice I circled, right? I didn't end up with y equals 587 or some other nonsense like that. So the reason that you can't end up with just a number answer on these is because there's no equals. And so it's a little scary when we first do it. If you've never done this before, when our instructions are simplify, very often we're going to end up with an expression as an answer. And so we need to keep that in mind there. So it's not hard. We just don't want to get scared at the end and accidentally by some strange magic end up making y equals 28 for some reason, right? We want to keep it the way it is. So we can't simplify, and we can't combine these. And the reason why we can't simplify it any further, by the way, in case that's another question you have, is we can't combine this with that because those are not like terms. Because this one right here has a y on it, and this one right there doesn't, right? So we can't combine them unless they're alike. Does that make sense? Any questions, put them down in the comments, or if you're in my class, you can ask questions through any of our normal question channels, including in class together. All right. Now, so let's look at, I said those aren't like terms, so we can't combine them. Let's look at a subtopic in here. Let's see what happens if we do have like terms. So we're going to look at combining like terms. I don't know if this gray is quite light enough. Is this pink hard to see? Let me know in the comments or in class or something along those lines. Combining like terms. We're still working out the kinks from this in this setup. It's a good setup. I like it. I think it's going to be really great, and we're going to be able to do lots of great things, and there's some upgrades that I can make to it later when money allows, but for now, it's as simple as it gets. So combining like terms. So let's teach combining like terms through an example. So let's do example 3, right? And let's throw let's throw in a dark blue and see if that's terrible to read or not. Okay. So let's do 6t squared. That doesn't look too bad to me on either screen that it's appearing on over here. Let me know how it looks for you guys. 6t squared minus 2t plus 8t minus 32. So which one of these four terms, there's count them, 1, 2, 3, 4 terms, which ones of these are alike? Well, this one's alike and that one is alike. Did I mess up? Did I try to get a little sneaky and make a problem off the top of my head and give us something that we are going to review later? No, this is a I think not. I think we're good. Yeah. So hopefully you know your integer rules. If not, I can put a link in the iCard to my video on integer rules, and you can check that out. It's an older video, so it's a different setup and all that kind of stuff. It's me writing on actual paper and those kind of things. But I do have a video on that. If you don't know how to add and subtract positives and negatives and multiply and divide positives and negatives and all of that, if you're in my class, hopefully you've been in my class before and know how to do it. If not, check out that video or ask in class. So, because we're about to use that is why I had to go down that brief rabbit trail. I wanted to make sure I didn't use something that you didn't know how to do. So if you don't know how to do that, click off, come back. Now, so what terms are alike? Well, this one's alike with that one. So what makes those two terms alike? And why is that one not like it? Because this one has a T and that one has a T and so does that one. The reason why this one over here is not like those, it's not a like term, is because that T is squared. So they have to be exact the same number and power of variables. So when we're combining like terms, it's really, really simple to do. All we have to do is we have to add or subtract the coefficients. And if we're not combining them, we're just going to bring down what we don't touch, right? We're getting used to doing that a lot. So we're not going to touch the 6t squared. So we're going to bring down 6t squared. My 2 went a little wonky, didn't it? Let's try that again. How about that? That looks better, doesn't it? Now, negative 2t plus 8t, the signs are different, so we subtract and keep the sign of the bigger one. So we end up with plus 6t. Easy peasy. We didn't touch the negative 32, so we're bringing down negative 32. And that's all it goes. We can't combine it any further. It's as simple as it gets. All of those things. No big deal, right? That we ought to be able to handle. Let's do, I think, unless I'm remembering wrong, let's do a bigger distributive property problem. All right, we're going to do one that has an equation that's we're going to use distributive property. Let me clear off this, make it nice and neat for us. So this one, the instructions are going to say solve. Right? So here we go. This is example, I think it's 4. If I'm wrong, I can just check, huh? Example, I was right. Example 4. Example 4. And we're going to solve. This is going to be the last example in this video, and then we'll let you go watch the next one or do homework or something else useful, like, taking a nap or something. So here's what we're going to do. So we're going to do 2 times the quantity 3x. Oh, yeah, I remember this problem. 3x minus y. Oh no, 3x minus y, close parentheses, plus 5 times the quantity x. Make sure I get this right, because if I don't, I'm liable to be in trouble. X plus 2y, close parentheses. And that, since it's solved, we got to have it equals. So equals 2 times y plus 5 times x plus 5 times 2y. Oh, I'm cheater, pumpkin eater. I am very tempted to re-record this video because that's annoying, because I read the problem wrong. But it's okay. I'm not going to. I make mistakes. You make mistakes. Everybody makes mistakes. The instructions are simplify. We're about to do a lesson on equations very soon. Soon and very soon, but not at the moment. All right, so we're going to simplify. So we're not going to have x equals 10 or whatever in the end, right? So we're going to simplify this thing. We got two sets of distributive properties. So how are we going to deal with those? Well, we're going to deal with them separately. So we're going to distribute the 2 right here. And we're going to distribute the 5 right there. Right? So we're going to do 2 times 3x minus 2 times y. And then over here, we've got plus 5 times x plus 5 times 2y. I know that's literally what I just wrote. Which is why I thought, well, this isn't the same. Of course it's the same. So anyway, now we got to do some simplification before we can combine like terms. That's the next step, right? So we've got this guy right there that we're going to simplify, and that guy right there that we're going to simplify, because we've got to do those multiplications. The rest of them, we're just going to kind of bring it down. All right, so what's in between that color? How about a yellow? That's not exactly in between, but kind of. So 2 times 3x is 6x. 2 times y is 2y, so minus 2y. 5 times x is 5x, so plus 5x. 5 times 2y is 10y, so plus 10y. Now we're going to combine like terms. So this one is like that one. 5x and 6x, those match, right? And these two match. So 6x plus 5x is how many x's? Well, 6 plus 5 is 11, right? So 11x. And then negative 2y plus 10y, those signs are different, so we're going to subtract and keep the sign of the bigger one. So it is plus 8y. So there it is. In class, we'll do some more guided practice problems. Your homework sets will be in your homework locations. If you just found this video on YouTube, then thank you for joining us. Remember that all of our Algebra 1 course lecture videos are available for free here on YouTube. We would really appreciate a subscribe and for you to hit the like button and, share it with your friends and ring the bell and all those things. Thank you for joining us. Let us know in the comments how we can help you with your math journeys, your science journeys, and your homeschool journeys in general, or if you're just needing some tutoring and you're not even homeschooled at all. Thank you guys. Have a great day.